Okay, thank you all for the invitation on behalf of HRTA. We are happy to participate in the event and even like this with a pre-recorded presentation. I hope this is interesting for your session here. Today we will be talking about mission critical technological gaps and research and development advancements in missions involving search and rescue operations in various environments. As you can see, as you will see in the presentation, we are active in several domains. Most of it in terms of research and development is focused on urban search and rescue, which is mostly for earthquake disaster events. Our team is the Hellenic Rescue Team of Arctica or HRTA. We were founded in 1999. 2000 was the first year of our first active year in missions after a large earthquake in Attica. We have three main elements and scenes of operation. The first one is the land element involving wilderness and mountain search and rescue, canyons, rivers, snow environment, and all this stuff. The second element is the water element, which involves sea, surface operations, underwater operations, also swift water, lakes, and all this stuff. Sometimes in floods too, where if the floods is it's large enough to be considered a scene for the water element. And perhaps the biggest scene of all in terms of number of operations per year is the urban search and rescue, which involves large-scale disaster events, either from earthquakes or from floods, from harsh weather, from all this stuff. We have also certified professionals for first aid and medical experts across the board for all elements. It is required for all operations and for all members of our operational teams. And also we have professionals for each specific element. We have mountain guides, we have trainers for scuba diving, we have EMTs and paramedics specialized for each specific purpose. And we are collaborating with the fire service in Greece and the special unit, the MAC team, mostly within Greece and also with some missions abroad. And some information about me in case you want to see it afterwards in the presentation, which will be uploaded. So we are talking about first responders and search and rescue operations. A few words about what is the purpose of these missions and how we plan these deployments. We have a specific set of priorities and a specific set of factors that we are considering when we are planning these missions. The first one is the first responder team, which involves, of course, as a first priority, the safety of the personnel, and also the situational awareness and the efficiency of the team in the ground. The second element, the second factor, is the victims. The focus of the mission is to detect the victims and get them out of the hazardous areas and provide medical aid if needed. And the third factor is the operations, which involves, of course, communication and coordination, and mostly the situational awareness, which is considered vertically. I mean, not only for the command center, but also on the team level. The situational awareness involves anything that has to do with sensing, especially remote sensing, management of assets and optimized deployment of assets, the logistics, the infrastructure, all this stuff. Now, the priorities that we are considering when we are planning the missions is mostly grouped in three main categories. The first one is the safety. We have to ensure the safety of our team. So any technology and any tool that we use within the team, one of the main purposes of these assets is to ensure the safety. This involves personal gear, for example, gas sensors, but also the greater scope of situational awareness, for example, to map the hazards, map the access routes, anything that has to do with making risks manageable and the team able to operate safely within this environment. The second is the speed. Which means that when we ensure the safety of the team, the second major concern is to get things done quickly as possible, but efficiently, of course. Get to the victims as fast as possible and get them out quickly enough for the paramedics to work with them in a safe environment. And the third one is the sensing. As I said earlier, the scope of this priority is to minimize the exposure of the team to hazards, which means that when we are using remote sensing, either with cameras or with, for example, UAV mapping the area for a wide area assessment, this means that we do not need to deploy the team within the hazardous area. Delay the deployment of the team within the hazardous area as long as possible in order to minimize their exposure to any danger. When we are assessing new tools and new technologies for search and rescue operations, there are a few things that we are considering. This is a short list. We can add several more items here. But these are some of the main factors that we are considering. For example, what is the main advantage, the main asset that we are adding to the team when the team is deployed within the work site, for example, in terms of earthquakes and collapsed buildings. What this new technology will bring to the team on the field. Also, what are the constraints in the tactical and the technical level? For example, we are using a geophone for detecting victims inside rubbles. What are the limitations of this technology? What do we have to bring together for supporting this technology, and what is the advantage for the team in operational terms? Does it minimize, does it shorten the time of victim detection, for example? And also other factors like what is the comparison to existing practices, if it is replacing some protocol or some other technology, what is the comparison? How is it integrated in the training plan and the operations of the team? All the stuff. And of course, the cost of getting this new technology and maintaining in the long term. Coming to specific examples in search and rescue deployments, we can think about, for example, the deployment of our team in Turkey recently. When our team was deployed in the large earthquake there, there was a special kind of environment due to the extent of the disaster area. As you can see here, it is several. I think it is about 130 something kilometers wide in total. Many villages and small towns with severe destruction in buildings due to bad construction and also the size of the earthquake. It was 7.7 and 7.8 in Richter scale. The diagram that you can see right here on the right is the number of victims recovered and saved during the first week or so of the operations. As you can see, the number seems small compared to the thousands of people affected by the disaster event, but it is important to see that most of the victims are saved within the first 2 or 3 days, which means that we have to work very, very fast and very, very efficiently in the first 2 or 3 24 hours of operations. Of course, the environment wasn't very easy to cope with due to the, as I said, due to the extent of the disaster and the collapses, the type of collapses, as you can see in these pictures here. We had some technologies with us, but for example, if you can use a thermal camera or something like that to assist in detecting victims inside this area here. But if, for example, you have a drone mapping the area, okay, you do it in the first few hours of the disaster, and then that's it. The drone cannot go inside the rubble piles. There are specific constraints in each technology. There are a few lessons learned from this deployment. For example, the reliability of communications inside the hot zone. We have to have reliable communications at all cases, even if the main infrastructure has collapsed, for example, the mobile network. We have to work with the support of logistics in terms of speed and in terms of range. We are talking about long range support in another country. Contingency planning, of course. Security issues. If the disaster area is very extended, the local forces and the local agencies cannot ensure the safety and the security in all areas. And many other conclusions that are described in the official after action report from USAR. Another incident in Greece was the large train crash in central Greece. The uniqueness of this incident was that it was night. It was relatively small in scale, but it was at night. It had very intense fire, at least for a few hours, and dense smoke, which means that in theory, while drones are helpful in mapping the hazard zone, in this case it wasn't that useful because of the conditions. And also rapid victim extrication was crucial because there were victims that required immediate medical assistance. Also, we have every year we have large wildfires in Greece and in other countries in the Mediterranean. We are working with the fire service in this aspect, in doing the best we can to isolate the wildfires when they happen. Of course, one major issue is mapping all these areas of wildfire in real time. This is marginally possible with satellite imaging. I mean, marginally for the state agencies and the organizations at the national level. It is not so easy to do to feed this information to the teams on the field. Similar issues with floods. These are two photos, one photo and satellite image of the floods in central Greece a couple of years ago, 3 years ago, which were very, very severe and extended in time, because it took a lot of time to recover from this. And this is a comparison of a village, for example, in Thessaly, before and after the flood. As you can see, it is not that easy even to get into this area to assist the people there. Our team was there. We worked with boats in order to evacuate the people after the flood, which means that in this case it starts as an urban search and rescue operation, but in the end you have to involve the water element, because we were working mostly with boats, small boats, inflatable, as you can see here. Now, we don't have the time to discuss all the issues involved in the problems that we have in this kind of operations. This is a small list. For example, I can comment about the last mile gap, which is something that it is not addressed in most cases. It is the problem that we have in the last few steps from the first responding teams up to the affected population. How do we inform them about the assistance? How do the people inform the first responding teams about their requirements and asking for help? This is mostly the task for spontaneous volunteers and things that are self-organized, which is not always very efficient to do, and it is happening after the first couple of days from the main event. Regarding the technologies that can help in this situation, there is also a big list that can be commented here. It is a big discussion, and it is actually the target and the focus of many calls for research and development projects in the European Union, the Horizon project, the previous Horizon project, and the Horizon Europe now, inside the DRS and other clusters. It is a big discussion. But mostly all these things can be grouped again into these three main categories that we said earlier. One is to assist the first responding teams, mostly in terms of safety. The second is assisting the victims in terms of mitigating the hazards and making their extrication faster and safer. And the third one is to improve the situational awareness, both for the command center and for the team. And this is done with sensing technologies, mapping technologies, and if possible, do this remotely in order to mitigate the hazards. Just a few more pictures. I won't take more time for this slot. Using, for example, thermal cameras inside the semi-collapsed building is helpful, but it is not. It does not ensure so that we are always detecting the victim. If the victim is injured, if the victim is hypothermic, we have this kind of problems. Another problem is that the UGVs that we are using today are marginally capable of navigating themselves within an unknown environment, especially if there is a fire or a smoke or a reduced visibility, as in these pictures here. We also need to fuse the sensing data in order to understand what is going on. For example, in the middle picture, you see a fire here on the spot, and also a lot of reflections of heat in the ceiling and on the walls, which means that it is not that easy to understand for the UGV, I mean autonomously, to understand what is going on. These are things that can be improved. Also, the mapping of hazards and pinpointing exact locations that the first responding team needs to be careful. These are cables after a large fire. We don't know if there is electricity in them or not. Also broken pipes, water running through the streets. All this environment is very dangerous, and all these distractions that you see here is just from fire or from flood. It changes the environment entirely. It makes it much more dangerous. In terms of USAR operations in a confined space, we also need to take care of the team and improve as I said, the situational awareness and how we work with the victims during detection and extrication. We have to be able to work in this environment quickly and efficiently, and several kinds of technologies can assist in this kind of operations. For example, pathfinding and marking access routes. This is an example of a large flash flood in Western Attica a few years ago. On the right, you can see the live picture, and on the left, you see the satellite picture from Copernicus, but a couple of days after the event. We need to make sure that this information is available during the event. And this is also another case with a large wildfire in Eastern Attica. Again, this is the situation on the ground, on the right, and on the left is the Copernicus map of the damaged area. Only 2 or 3 days after the event. We need to make sure that these are information that can be used almost in real time. What is happening with the research projects, especially in the Horizon projects, is during our involvement with this project in the last 10 years, we have a few lessons from what can be done and what can be improved in this project. For example, the early end user involvement is crucial for the successful completion and actual output of these projects, because the end users should be involved in all the stages, not just in the requirements and the testing at the end. Expectation management from all sides, from the technical sides and from the technical side. Extensive field trials throughout the plan. If the project, for example, is a 3-year project, we have to incorporate several phases of field tests and trials, not just in the end. Standardization and interoperability is crucial in terms of integrating these new technologies in the first responder teams and in real operations. And of course, for the partners involved in these projects, they have to have some advantages in funding especially for IPR and exploitations of these new technologies in order to have the appropriate incentives to do so. A few logos from our projects that we are currently involved in 3 of them. 3 of them are active right now: the 6G Versus, the Karma, and Synergize within the Horizon framework. All of them are DRS related, not specifically DRS, which means that the Disaster Resilient Societies is the DRS, which means that we are working towards improving all these technologies, from remote sensing, from UGVs, AUVs, mapping, wide area assessment, victim detection. All these technologies are relevant in this case. This is a paper that we published a few years ago in the ISCRAM conference. It describes all these things in much more detail, and whoever wants to get into the details of specific events like the large flood that I described earlier, or the wildfire in Mati area in Eastern Attica, you can find more information there. And with that, I thank you very much. And of course, if anyone wants to ask any questions or get more information about how these technologies are used and what is coming in the next few years in these areas, of course, I will be happy to answer these questions. Thank you very much.